Is the presentation visible now?
No, sir, the same issue is still continuing. Don't know
Okay.
why.
What it's showing for you?
I'm uh, I'm getting a message that we have let the organizer know that you're waiting. It means that I'm in a lobby, waiting lobby. I have not joined the meeting.
But we are talking, right? But I have accepted you inside the lobby. Like you are not in the lobby. That's why we are able to communicate. Wait.
Yes, I can hear you.
Yeah. You're not able to see my presentation, right?
Yes, sir.
Now you're able to see.
No, sir. So hold on, I'll just rejoin the meeting.
Can everybody see the presentation? Hello? Hello? Am I audible?
Yes, sir, you're audible, but we
Uh,
can't see your screen.
you can see my presentation?
No, no, we can only see your video. I cannot see your presentation.
Okay. Mm, Now you can see the presentation?
Yes.
Okay. Okay. We will wait for a few minutes. If other people let other people know. Guys, can you able to hear me, or is the presentation visible?
So I am able to hear you, but I can't see you see your presentation.
Yeah, yes.
Yes, sir.
Okay. Any anyone else not able to see the presentation? Everybody else is able to see the presentation? Am I audible?
Yes, sir. You're perfectly audible to me.
Okay, this is Yash, right? Can we start the presentation? Do you want me to wait? Okay, uh, I'll start the presentation. Good evening, everyone. I'm Divyanshu Sekarwar. I'm currently pursuing my PhD. I'm first year PhD student at IIT Delhi, and uh, this session is for uh, basically to provide a summary and solve few problems uh, regarding the course which we are studying in NPTEL Integrated Waste Management for Smart Cities. So basically we will do a little bit of summary of the things which you have learned in the first week, as well as we will do few problems uh, at the end of the session. Okay. One thing I want to convey that the version I'm using for Teams only allowing me to record the session for 1 hour. So probably after 1 hour, the meeting will get disconnected. So we will start the session again. If the meeting get disconnected after 1 hour, please uh, join again. Okay. So from the next meeting, I will uh, try to change uh, the version of the Teams so that we can directly go for 2 hours. For today, I request you to rejoin at the end of 1 hour. If the meeting get disconnected, we will continue the meeting after 1 hour. Okay.
Hello, sir.
Yes, yes.
Sir, can I suggest you to keep the meeting next time on a Google Meet?
Google Meet.
Because
Yeah.
I don't, yeah,
Okay. I will.
because I'm facing some issues over here in the Microsoft Teams.
Okay. Well, I will try to
I can
update.
only hear your voice.
Okay. I will try to update it to Google Meet. I have to send the link to NPTEL. Then they will update the meeting to Google Meet.
So, sir, I'm not even able to look at the presentation currently.
Okay. Okay. Other people are able to see the presentation.
Yes, sir.
Okay. So yes, probably there's some issue at your end. Next time I will try to shift to Google Meet and I will post the presentation so you can see.
Okay, sir, sure. Sure. Thank you, sir.
Hmm. So we can now start presentation. So first we will understand what is solid waste and why do we need to manage it. So basically waste resulting from human activities such as dead animals, waste on street, institutional waste or commercial units. So basically the classification can be in two ways, like anthropogenic waste and geogenic waste. So anthropogenic waste is basically waste which is generated by humans, and geogenic waste which occurs naturally. So here in solid waste, basically we talk about municipal solid waste. So in solid waste, we basically talk about only municipal solid waste. So in municipal solid waste, basically there are two classification: domestic waste, where we include waste from cooking, cleaning, basically from kitchen, and other activities like tea, decoration, plastic, glass container, packaging, the packaging, and clothing, papers. Those types, these types of things comes in domestic waste, and other is institutional waste. So the only the source of generation is same. The type of waste is almost similar. Like waste generated from offices, department stores, but the type of waste is same. Like food waste, packaging waste, same type of waste is generated from both the locations. So moving forward, so why we need to manage waste? Why there is a need to manage waste? So there are, if we just dump the waste in open, there are some adverse effects of the open waste dumping on the environment, or we can also call it the unscientific disposal of waste. So the adverse effect or disadvantages are like it affects the soil and ground by polluting the soil and ground. If we directly throw the waste on ground, there will be rainfall, and the waste will get decomposed. So there is a process called leaching. Leaching is a process where toxic compounds get leached out from the waste into soil, and further those compounds travel through soil into groundwater, and then they contaminate groundwater, and we use groundwater for drinking purpose. Okay, drinking purpose. Then second is pollution of air due to bad odor. So if we are just putting the waste directly into open site, there will be pollution, because when there is decomposition, whether it is aerobic or anaerobic decomposition, it will depend on the availability of air. If we have air, if it is open dumping, then obviously there will be aerobic decomposition, and there might be some anaerobic decomposition at some depth if the height of the waste dumping is very high. There might be some anaerobic decomposition at the lower depths, but it will be aerobic decomposition. So gases which come out of the decomposition can pollute the environment. In case of anaerobic decomposition, there will be emission of gases like methane, and methane is a gas which has global warming potential. So global warming potential means uh, it can absorb heat from the surrounding. It can capture heat from the surrounding, and it holds that heat in the surrounding for a long period of time. So there is increase in the average temperature in our surrounding. So like global warming, there are many gases which uh, have higher global warming potential, and we measure their global warming potential in with respect to CO2. So CO2 is a basic gas. Uh, we take it as like a data. and we measure the potential of other gases like methane and SF6, and water vapor is also a greenhouse gas. But water doesn't have that much compared to CO2. It is the glowing potential is very less. But the majorly which gas which is produced in from solid waste is methane. And methane has around 25 times more global warming potential as compared to CO2. So coming to third point is the generation of greenhouse gases, which we discussed. And further comes the open dumping of waste invites rodents like rats, flies, and mosquitoes, germs, and other insects. And uh, these things will carry bacteria with them of different diseases, and these rodents will travel to our house, and then these diseases will get transmitted to humans. So the prime example of this is bubonic plague in 14th century, which we will discuss further. So basically, the open dumping of the solid waste will lead to rodent flies and mosquitoes, which is does not create unhygienic conditions, which further causes health problems. Further, open dumping also, like normally in India, there's a lot of open dumping in different wards or different sectors. There will be just beside the house there will be open dumping. But we have in India we have culture of rag pickers. But the rag picking, the, the collecting waste or picking something useful or recyclable from the open dump is also harmful for pickers, because we don't provide any PPE to rag pickers. They just with naked hands they pick things from the waste, and which is harmful for the health of rag pickers also. And further, all these conditions basically increases the chances of different diseases. So moving forward, guys, did my slide move to the next slide, or is it stuck?
It moved.
So next, so the things we discussed was what is solid waste and why to manage it. So how do we manage it? We do manage it by solid waste management. So what is solid waste management basically? So in general context, if we see from the past, when we uh, dispose of waste, it is basically open dumping. So in current context, that open dumping translates to landfills, engineered landfills, where it is not basically open dumping. We do things in landfill, like we provide lining so that there is no contact of the harmful substance called leachate, which is generated in landfill. It does not percolate to soil or the groundwater. So, but the thing we want to do is we want to reduce amount of waste which goes to landfill. So for that, we have various precursor steps to direct dumping to landfill. Like uh, first thing we can do is prevent the amount of waste generated, and we can do recycling. Whatever waste, whatever things we are using, we can reuse them. We will further discuss these points later. Further, if we have organic waste, we can do composting. So these are the things in which ways we can manage the solid waste. So further, there are four basic ways in which we deal with the uh, solid waste. First is dumping, open dumping, which we have discussed many times. It is the most used way, most natural way of dumping the solid waste, uh, and usually the dumping of waste. If we are doing it in a city context, normally the dumping is done outside the periphery of the city and normally in the low-lying areas. So second is burning. Often burning is done in terms of in uncontrolled way. We are not doing burning in incinerators where the air pollution which is generated from the burning is treated. Basically, in burning, we are doing normally it is uncontrolled. So, primary example of uncontrolled burning, which we can see is also visible how harmful the uncontrolled burning is or open burning is. We can see from Delhi pollution also. So, there are many reasons for Delhi pollution, but some of the major chunk of the pollution is contributed due to uncontrolled burning. So, we like within Delhi, people just burn tires or solid waste, and which causes a significant amount of pollution in Delhi. There are various other reasons for that, but one of the reasons is uncontrolled burning. In further in burning, now we have technologies like in the incineration, we can do pyrolysis, which is basically called thermal treatment of wastewater. But the problem with incinerator or controlled burning is it is on the costlier side. The third component is recycling. So in recycling, basically we recover the beneficial components from the waste which we have generated, and we can also separate the hazardous waste from the waste which is generated, and we have to ensure that hazardous waste doesn't get into landfill, because once if it get into landfill, it becomes a problem further to manage once it gets inside the land. The fourth component is waste minimization. So waste minimization we can do at the reducing the amount of material which is used at this source. So we can reduce the amount of resources we use to make particular product, or we can reduce the amount of energy which is used during manufacturing. So basically, making the process more efficient. If you able to reduce the amount of electricity used in particular process, you basically uh, reducing the amount of coal burn, which will further influence the amount of ash generated. So in that way. So moving forward. So if we do solid waste management, there are various advantages to solid waste management. So those advantages like environmental health and safety benefits. So if we are doing a proper solid waste management, it helps in preserving the environment by preventing the contamination of soil and water, as soil and water can get contaminated if it is open dumping or unengineered landfill. If dumping is done in open dump sites, their uh, leachate formation will be there due to anaerobic digestion, and that then percolates into the surrounding soil and the groundwater. Second is second thing if second second will be by doing solid waste management. We basically what we do is we divert the waste from landfill. So if we as we know that continuously Normally, a solid waste dumping site or landfill is created outside the city parameters. So, but as the city grows, that dumping site will get integrated inside the city boundary because city is growing. And as the city grow, we require a larger dumping site also. So if we want to sustain a same dumping site for longer period of time, we need to divert the amount of waste from the landfill so that the same site can be sustained for longer period of time. So in that sense, we need the solid waste management helps in diverting the waste from the landfill. Further, the more amount of waste there will be landfill, there will be more chances, more will be the amount of generation of leachate. So in that sense, it reduces the impact to groundwater as well as soil and air quality because there's generation of various gases like methane, CO2, and slight portion of hydrogen sulfides and other gases. Further, the third benefit will be like in the indirect sense. Like once if we reduce the solid waste generated, how can we reduce the solid waste generated? Here we are reducing it by reducing the amount of virgin material use. Like for understanding this point, we can take the example of aluminum cans. So for in if we use the aluminum cans, reuse or recycle the aluminum cans, we don't have to mine aluminum. We don't have to mine aluminum ore again. So that will lead to around two-third reduction in the energy consumption. So there will be around two-third reduction in the energy as compared to if we mine the ore and then we make a new aluminum can. Uh, and contrary to that if we recycle the aluminum can, we will be able to save two-third of energy. So in that sense, two-third of energy means just assume if we are using coal, uh, so we can say that we can save two-third amount of coal which we use as compared to the virgin material. So in that sense, we are uh, reducing the amount of renewable energy use or renewable fuel use, which further have positive impact on surrounding by reducing CO2 emissions and other gases. Continuing further, uh, so as we discussed, the landfill because there is anaerobic digestion in landfill, there is formation of methane. And methane has uh, global warming potential as it is 25 times more and heat and trapping capacity as compared to CO2. So if we are using engineered landfill, we can capture or we can collect the methane, and then further methane can be used as a fuel. So it gives two advantages. If you are preventing the emissions of methane into the environment as well as you are capturing the methane and you can use that methane as fuel, so which basically it will reduce burden on the fossil fuels. Then further is waste prevention and recycling, divert organic waste from landfill. If we uh, if we use lesser material, like in case of with technology, our laptops or chips are getting smaller and smaller, it means comparatively smaller amount of material is used. And at the same time, the example discussed in the class, where rather using a disposable cup, if we use a steel cup or a cup which we can use multiple times, so we are indirectly reducing the amount of waste generated. In similar way, if we do composting for organic waste, so that organic waste won't end up in landfill, So in that way, we are diverting the waste, uh, converting into a compost, and that compost can be used in agriculture, which in some form will reduce the use of fertilizer. So in that way, in an indirect way, we can reduce the amount of waste generated. And the last thing is, if we manage the waste properly, we reduce the spread of diseases. Apart from environmental benefits, there are many economic benefits also, which you might have uh, got the idea from the environmental benefits also. The economic benefits, like if we divert the quantum of waste, or we do recycling, so you basically reduce the consumption on your end. You don't need to spend money on new things. So in that way, it reduces the cost. Further, it also reduces because the amount of waste diverted to landfill is reduced. So it further reduces the landfill cost, as there is a transportation cost also uh, attached to the landfill, because once you collect the waste from the different houses, you have to first, with smaller vehicles, you take that waste to stations are basically middle point stations between your homes and landfill site, where small vehicles will bring the waste, and from there a larger vehicle will collect the waste, and it will take it to the landfill site. So in that way, a smaller amount of waste need to be carried from homes to the landfill site. So so you will require lesser number of vehicles, so which will cost the transportation cost. Uh, so basically, uh, these 3 points basically include the things which I just explained. In last point, we can say that if we are reducing, reusing, and recycling, we don't have to buy new materials. So we can, if something is not useful for me, I can give it to another person, which when that person if that person has use for that particular thing. So that person has don't have to buy a new thing from the circular chain, from the market. So there will be reduction in demand for that particular thing. So at the back end, there will be production of that thing will be reduced. So in that sense, also there will be an economic benefit for that. Uh, as we know that waste management is also a labor intensive activity. You might have seen that in your particular city, when the vehicle comes, there will be two or three people in the vehicle who are going home to home and collecting waste. And when this waste, which is collected from your home, gets to the transfer station, there will be rack pickers and other stuff which basically do the segregation of waste in some sense. They basically pick out plastic bottles which can be directly resold uh, to the companies which can recycle those bottles. So in that sense, it it is a labor intensive job, bu- and for ensuring the safety of the labor, we also further need the PPE also. So there, in that sense, if we reduce the amount of waste, the amount of labor required to manage that waste will also reduce, and which will reduce the cost required also. So further, we will look into the history of the solid waste. Uh, in ancient times, normally the waste was directly thrown um, in either in the boundary of the cities or directly into the unpaved streets or roadways. The very first time this practice was checked was in the city of Athens in 320 BC, and During that time, disposal methods were very crude, and they were just disposed of in open pits located either beside your house, or if people were paying more attention, they were disposed in the city boundary. So as population increase, uh, as the population increases, the city expands. But with the expansion of cities, the disposal sites at boundary will also get included in the city itself. So that pit which was intended to be outside the city so that there is no smell, there's no spread of disease. Now that site is within inside the city, and it will cause problems. So the prime example of uh, this health consequences of open dumping is bubonic plague. Like where the because of the open dumping, the bacteria got transmitted from rat to the flea, and then flea to human beings. So in 14th century, it almost led to death of 50% population of Europe. And then there is another case which um, Sir mentioned during the class, which was Love Canal tragedy. Uh, Sir suggested to view any documentary or video on Love Canal tragedy. Did anyone of you went and checked anything about Love Canal tragedy? Hello, am I audible?
I couldn't see.
So what happened during that time was there was one person called William T. Love. He actually owned the land near Niagara Falls. So there was vast patch of land, and he wanted to construct a canal in that area. So that he can connect the lower and upper part of Niagara Falls and use that water to generate electricity. But that plan was discontinued, and later, after 10-20 years, that canal was turned into a municipal and industrial chemical dump site. After few years, that the government, the city or government acquired that land, and they just covered the waste with some earth, with some soil, and they constructed homes over that land. So what happened was, after some time, there was heavy rainfall, and uh, because of rainfall, that the toxic waste got leased out, and it traveled in the upward direction with water. Um and the dumps which were the waste which was dumped buried in that site, they were basically cans in containers. Waste was there, so those containers resurfaced uh, at in the that Love Canal, and because of that, there were about 82 different compounds which got leased out in that area. In that area, there were around 100 homes, and out of those 82 chemical compounds, 11 compounds were carcinogenic. So because of that, the people living in that area faced many problems. Like there were many birth defects in people, and whenever children used to go to play, they will uh, they will have a faint smell or choking sensation or choking smell. And whenever kids used to go to play, they will come back with burn on their hands and faces. So this type of problem happened in around 1973. After that, the government took action to clean that site. Similar type of scene you can see currently in Delhi also, where there is a huge open dumping site basically. So there's leachate. Whenever there's leachate, and sometimes there's also fire, also open fire also, because of methane. So that leachate get collected around the open dumping site, and that leachate is now influencing, because that leachate contain many carcinogenic compounds. Uh, it has lead also get leached out with acetate, which is formed inside the landfill. So now the surrounding area of that dumping site in Delhi, people are facing health issues. So further coming to the present day, normally in solid waste management, basically there what we're doing normally read is 3R principle, where it involves the reduce, reuse, and recycle principles. At some places, you will also see 5R and 6Rs also. So in 3R principle, where we see reduce, reuse, recycle. So in reduce, uh, we try to make we try to reduce the consumption of material for making something. So uh, for example, if if we take the example of Amazon delivery products, uh, we see that the outer packaging sometimes is way oversized than the actual product. So in those cases, the outer packaging could be reduced. So it will directly reduce the amount of packaging material required. So in that sense, we can reduce the amount of material required at the source, so that lesser amount of waste is generated. Second is around reuse. So reuse is basically the same example. I will give the same example discussed by Sir. Like if we are using a coffee mug, so rather than using a disposable cups, we can utilize multiple number of times. So in that sense, reuse of some material will reduce the amount of waste generated in long and short term. In case of recycling, we can take the example of the aluminium cans. In case of refuse, uh, you can basically avoid the unnecessary use of some materials. We can take the example of the again Amazon packaging. In some cases, if we don't require uh, unnecessary packaging or oversized packaging, that can be taken as from company side, that can be taken as to avoid that unnecessary packaging, so that there is not unnecessary wastage. In case of when we order food at our home, we can, and the good example is when we select for avoiding cutlery, and we don't we avoiding cutlery from the delivery. So that is also an example of refuse, and in that way you basically avoid the amount of waste generated. The last one is fifth R is in sense of repurpose, or some places it is also given as rot. So in case of repurpose, you basically, if I'm using a Bisleri bottle, if I cut the Bisleri bottle and use it as a pen stand, in that sense, you repurpose it in another form, using dry waste in decoration. In that sense, you can repurpose things. And there is another art called rot. In rot, basically come is regarding the composting of the organic waste. The organic waste which we are generating, we can generate compost and we can use it as fertilizers. So so when we talk about the solid waste management, there is one important aspect which comes into picture, which is life cycle assessment. So we will also talk about the life cycle assessment. I want to convey one thing, that currently my team is only allows me to record go on a meeting for 1 hour. If our meeting get disconnected, I will again start the meeting. So I'll request you to please join again. From next time, I will sort out this issue. Okay. So continuing forward with life cycle assessment. So life cycle assessment. So basically, if we see the life cycle of any material, or life cycle of any product, basically we take a raw material, we process it, or do manufacturing, then we distribute it, at, and then we use it, then we directly throw it out based on whatever material we are using. or either we can uh, repurpose it in some sense, or we can extract some resource, some material which can act as a resource for again generating a new product. So in that sense, we can see as a life cycle of a certain product. So, but in life cycle assessment, what we do is uh, I will try to explain it with an example. Like if I'm trying to construct a wooden hut, I'm trying to construct a wooden hut. So the different material which I require for constructing that wooden hut will be uh, I need wood, I need nails, uh, and I need some binding material, some type of glue or some glues or something to attach the wood, or we can also do it by nails. So if for us, let's assume we need for now we need two material, wood and nails. So for now, if we assume we need wood and nails for making the wooden hut, so we know when we if we need the wooden pieces, there will be different processes which have involved in making that wooden piece. Like right from cutting the tree, after cutting the tree, we need to transport that tree to a particular site where we have to do seasoning of the tree, seasoning of the wood, and for the seasoning of the wood, we require heat, and for the transportation we require fuel. So in that whole process there's lot of energy, lot of resources which has been involved. Similar goes in the case of nail. For making that nail, we have to mine iron, then we have to extract iron from that ore, then we have to make nails. uh, in extraction of iron, then we have to go to blast furnace, and there's a whole process coming from iron ore to that particular nail. So, so in life cycle assessment, what we do is right from the raw material, uh, uh, right from the extraction of raw material uh, to the end of its life. Then, when we if just let's assume if we now in that hut after 20, 30 years, that hut we can't use that hut anymore. So now we have to deconstruct it now. But after deconstructing also, maybe we can use some of the nails, maybe we can use some of the wood if it is not uh, if not completely rotten, or in some sense if we can use that wood, or if we can use that wood for burning. So in that sense, the life cycle, what life cycle assessment do is it analyzes a particular activity, particular project from right from the raw material uh, till the end of his life, and then again, if in any way if we can reuse the material from the end of the life of the product. So in life, in that way, we analyze what are the impacts on the environment in life cycle, in environmental life cycle assessment. We analyze basically in the complete whole process, what are the impacts on the environment, from like if in this example, from the making of a hut, what will be the impact on environment. So that impact is basically determined in various categories, or various uh, indicators. That has various indicators which we will discuss in this slide. Before that, when we do life cycle assessment, we need to define, the first thing we need to do is define boundary. Like when I was explaining the hut example, the wooden hut. So like what boundary I want to keep. So that we can understand from this figure also. Like we can see the phases of our life cycle, like production stage. If we only want to consider uh, from the preparation, from the raw material to the till the production, we don't want to include the usage stage or end of the life stage, that will be called cradle to gate. This thing was also discussed in class by sir. And if I want to include from right from the raw material to end of the life, So if I want my boundary for life cycle assessment from cradle to grave, then I will include the preparation of from the raw material till the disposal end of the life. So there is one more concept called cradle to cradle when you complete the whole cycle, right from preparation of raw material, then you go to uses, then end of life. Then at the end of life, you will have some uh, waste material which you will find try to find the reusability, and then that reusability will again come to will act as a raw material. So that scheme is called as cradle to cradle. So this is the the first thing which we define. First thing which we do in life cycle assessment is define boundary, like how much we want to analyze. So uh, once we analyze the whole process, we do it in like what we do is we come up with uh, the impact what is the impact on the environment of that particular process. So we can see that from this figure. uh, for first is an environmental interventions. So if we are using a particular raw material, so we have to extract that raw material. So in the process of making something like that wooden hut, is there will be any air pollution or water pollution, whether there will be any physical modification in natural area. So physical modification in natural area means if I'm constructing a hut, I need a land area. So whether that hut which I have constructed in a particular land area, that does that hut influences the ecology of that environment. So if the ecology is influenced, then it will impact. If the ecology is influenced, it might influence the surrounding life. Like it might influence the surrounding animals. It might influence the local insects in some way or another way. If the physical modification is impacting the ecology around, and or the construction of that hut is causing any noise pollution. So these factors we consider. So based on these factors, we end up with two types of parameter which are called midpoint parameters and endpoint parameters. So in midpoint parameters basically include parameters like global warming potential, which is included in climate change. Climate change we measure by global warming potential, normally in terms of CO2 equivalents, and for photochemical ozone creation. Basically, if there is too much nitrogen oxide present in our lower atmosphere near the ground, then due to presence of sunlight, there will be formation of ozone. So this that is called photochemical ozone creation. If we have ozone uh, in the near to the Earth's surface where we live, so ozone is highly oxidative in nature, so it is harmful to our health. So that parameters is also measured. Third is third is eutrophication and acidification. Eutrophication is when different
So,
yes, yes,
hello.
yes, yes,
So sorry to interrupt you. I had a question regarding the life cycle assessment.
yeah, yeah, yeah.
So when is the life cycle assessment done? Before the production or before the after the production? Means of any material, for example, plastic bags and all.
It can be done at both times. Like if I'm before also, if before also you do, it can help you in making taking decision whether you should do that activity or not. Like if I'm doing in certain, like for take an example, just I'm working on certain project and certain technology, and I want to analyze that technology. So whether I should go in that direction or what improvements I should do in that technology. Once for for ex- for example, I'm working in a technology called bioelectrochemical systems. So MFC, it is basically I'm using a wastewater to convert it into hydrogen. So I want to check whether the different materials I am using in this technology or I'm going to use in this technology, what is the impact of those materials on environment already? And when whatever gas is produced from that technology, whether they will be harmful for the environment. So it can help in taking decision both times. There's currently existing some system or currently existing some technology. If we don't have LCA for that, we can do LCA and we can come up with improvements for the technology. How can we reduce the impact of the technology? If we want to develop certain technology and we are working in that direction, we can do LCA and we can determine during the time of development whether we want what improvement we want to do. Is it okay, Yash?
Yes, sir. Got it. Got it. Thank you, sir.
So in eutrophication, basically minerals like nitrogen, phosphorus, nitrogen, they get leased out from the soil and they go to the water bodies, and there will be generation, there will be formation of algae in the water bodies, and sunlight won't able to penetrate inside the water body, which leads to the death of aquatic life. So which is also an environmental impact. So that potential is also managed in uh, in various impact categories. So these fours are basically midpoint indicators. These basically tells an information about like what are the influences, what are the different impacts on the environment. And now from and the apart from midpoint indicators, there are endpoint indicators. So in endpoint indicators, uh, how these midpoint indicators influence endpoint indicators. It's like if we take human health, so there are many and apart from these four, there are other and midpoint indicators. So like each different and midpoint indicator can influence a single endpoint indicators. Like human health can be influenced by global warming potential, which is including climate change, or by through acidification, through photochemical ozone creation. So in endpoint indicator, we like human health can be influenced by these and midpoint indicators in various proportions. Like climate change might influence more as compared to acidification. So in that sense, at the end of the analysis, you will get endpoint indicators, which will be human health, how much these indicators or the construction of that hut influences the human health. Then there will be how much resource depletion will be there, and how much that construction of hut, the example we took, how much that influences the ecosystem uh, quality, in sense of the material, like we are cutting the wood and we are constructing that hut in particular area, so it might be influencing or affecting that particular ecosystem. So LCA, this was just an introduction to LCA. Further LCA will be discussed by sir later on. It was give just to give a peek into LCA. So further, moving forward, uh, waste moving forward with waste management hierarchy. So Okay, let's wait for 2 minutes. Like other people join. Okay, let's. I will continue from the waste management hierarchy. So basically, in waste management hierarchy, uh, it, there's an pyramid where based on the importance of particular uh, based on the importance of particular method, it is arranged. So like the least important or least favored method is disposal, which we already know, which we have discussed. Like our only aim, if we can say that our only aim is to divert the waste from disposal or dumping sites. How we do that? We do it. How we divert the waste from the dumping or disposal site by these other methods, like the recovery, by recovering the energy or waste, uh, some material which we can recover from the waste, by doing recycling, reuse, or avoid or reduce. These things we have already discussed in the 5R system. In 5R system. So so here from the diagram we can see that disposal is the least preferred, and the thing which we want to do is we want to reduce the waste which is generated at the source itself. We want to reduce the amount of material reused at the source itself, so that there is less amount of waste produced. So in that way, we can see this hierarchy. But the thing is, in most of the countries around the world, almost more than 90% of waste goes. Is it visible now? Sorry, I actually forgot to share this screen. Okay. So from the diagram, we can see that disposal is the least preferred, and our only aim is to divert the waste from the disposal, and reduction and reduce at the source itself is the most preferred thing. So here we can further discuss about the various elements of waste management system. So in this diagram, we have a flow chart where we have the six elements of waste management system, which is waste generation, second is segregation, storage, third is collection, and there is separation, transfer, and transport, and is processing and recovery, and then it is disposal. Normally, where we can there is different ways where this six element can be arranged. In some cases, you might find that uh, like in most of the cities in India, there is waste generation. There's no segregation or storage at home. There will be some collection system, but most of the waste will directly go to disposal site. In some cities, you might see there will be segregation and storage at homes, and there will be proper collection, and then that collected waste might go to transfer station. And after transfer station, there will be bigger vehicles that collect that waste from transfer station. Then it might go to some processing like composting or refuse derived fuel facility, MRF facility. There, they basically uh, do segregation of waste where they can take out waste which can be recycled, waste which can be composted, and after that it might go to disposal. So the different we can discuss each component separately. Like for waste generation, um, normally the waste generated at home is normally domestic or industrial waste, which we discuss in the first or second slide here itself. I will further explain this waste management system from an example. There's one case study which I did during my MTech. So there's one example of Jaipur city. I will show that example. So we'll discuss in short later, maybe in later classes. I will discuss the whole study. I will just for now I will just show the overall the waste management system in Jaipur city. So in Jaipur city, recently from the time of COVID time, there's door-to-door collection. Before that, there was no door-to-door collection, and directly the waste was just dumped within a colony. There will be some site or there will be some road of intersection of roads, and at that side only waste was dumped. But from last few years there's door to door collection, and then that the waste which is collected in small vehicles, which you can see in the photos also. There will be waste collected from the houses, and then that waste is taken to a temporary transfer station where the rag pickers basically segregate the products which they can sell, which there is a demand in the market, like plastic bottles and those kind of things, which can be recycled. So, but they don't wear any PPE, they don't have any personal protective equipment for any safety. If there is any syringe or such type of waste, then they easily get infected, or in that sense they get health issues because of that. And from transfer station there will be one bigger vehicle which will collect waste from the transfer station, and that will be carried to a landfill site. Basically in Jaipur there are three dumping sites. Out of those three some dumping sites, there's only one properly engineered landfill. Other than the other two are basically open dumping sites. So in this process, there is some like after transfer station, uh, there's a refuse derived fuel facility also. There's one manual sorting facility, and some of the waste is redirected. Which is wet waste or organic waste is directed towards composting also. After all these process, whatever waste is left, they directly is dumped to landfill. So this is a small example of for Jaipur city how it is done in Jaipur city. We'll again go to our presentation. So uh, if, moving forward, I have few questions, around 20 questions to discuss. If you want a 5 minute break, we
I
can
have
have,
processed, you had a diagram wherein you have highlighted how the entire thing happens for the case study.
yeah, for Jaipur city. Yes.
So, all of the dry waste goes into RFD, be it the plastic or whatever.
Not really. Like this is like this diagram is more sort of ideal condition sort of way. Most of the plastic waste and plastic waste or recyclable waste get picked up by rag pickers at transfer stations itself. Like in this photo, like this person is basically a rag picker only. He's segregating the plastic waste, bottle waste, which he can sell to a person who will give some amount for that plastic waste.
Okay.
So yeah,
Majorly, I wanted to understand: are they doing waste burning or
no,
RMT creation?
no. In most of the cases,
Okay.
it is more of like a proposed thing. I did this
Mm-hmm.
study in around 2 3 years back. So at that time, what they do is whatever waste which can be burned or incinerated. In majority of the cases, what happens is that waste will be sent to nearby cement manufacturing plant for directly for burning. There won't be dedicated incinerators, majorly because of the high cost, and um, there is social stigma around incinerators because they cause air pollution. If you don't have a proper dedicated the air treatment facilities which is generated from the incineration plant, they can cause like they could be emissions of dioxin, furans, and other compounds. So normally, what I have studied according to that, most of the times they will be sent to nearby either thermal power plant or mainly cement manufacturing plants.
So, in India's context, do we do incineration anywhere or no, not really?
In Indian context, I'm not aware actually. In Indian context, I don't know. I will check. But in outside India, there are incinerator plants.
Yeah.
Yeah,
Yeah,
like
I'll answer this question.
yeah.
Yeah. Hello.
Yes, sir. Please, sir.
Yeah.
Please, sir.
Yeah. In Indian context, we have almost all in Delhi itself, we have three incineration
Yeah.
plants. Visakhapatnam, there is one plant which is operational,
Mhm.
and typically in Ahmedabad they are planning. And in Center for Science and Environment, if you can see, there is a book called Burn or Not to Burn, where we
Yeah.
have almost all planning for 600 incineration plants in India,
Yeah.
out of which in the small scale level there are about 120 operational, uh, and more of them are not in operational now. But our ministries are planning to have more like 600 plus incinerations in and around in India by 2025. So that's the
Mhm.
action plan. It is there.
Yeah.
So incineration plants are available, but there are many challenges in the Indian context.
Yeah.
Hope
Mostly
this answers the.
yeah. Yeah. Thank you, sir.
Yeah, it does.
Thank you. The like problem with Indian waste is like first thing is we are not able to segregate it. Second thing is the calorific value of the waste we generate is very low. So we can increase the calorific value by segregation, but because we don't have source segregation, so the wet waste proportion is also on the higher side. If we have more water, also it reduces the calorific value. So it basically require more heat to burn the waste. So those are few problems with in specifically in Indian context. So moving forward,
Okay, thank you.
yeah. Okay, so I have few questions, like around 20 questions. If you guys want, we can take a 5 minute break and then we can start, or we can just complete. I can continue.
So yes, please continue.
Yeah. So the first question is which gas is produced in open dumps from anaerobic decomposition of organic waste? So if you want, you can answer in the comment section, or like in whatever way you want to do it. We can do it as in the sense of quiz, or Yeah. So in anaerobic decomposition, basically methane gas is produced. So we can also discuss about the anaerobic decomposition. So in the process of anaerobic decomposition, basically it's a four-step process where the first step is hydrolysis, second step is acidogenesis, third step is acetogenesis, and fourth step is methanogenesis. So methane is a byproduct of the fourth step, which is methanogenesis. Okay. Okay. So the answer is methane formation. So methane. Second question is what is the thickness of geomembrane in geomembrane liner in a landfill? So as discussed by sir, there's in double liner or single liner system we use geomembrane. Basically, geomembrane is either a very low permeable or impermeable uh, geotextile, basically. So which it's basically an impermeable permeable membrane which prevents leachate from moving from landfill to the soil and further into the groundwater. So the question is, what is the thickness which is used for the geomembrane? So the thickness for the geomembrane liner is around 60 mil. See, the correct answer is A. Um, the thickness is around 60 mil. 16 and 1 mil is equal to 0.001 inches. So if you convert it into centimeter, it will be around 0.1524 centimeters. So we can further discuss on the on geo use of geomembrane in landfills. Normally, in open dumping sites, the geomembrane is not used. And in engineered landfill, only there will be a certain layer of uh, there will be one around 2 feet of soil layer which through which the leachate could percolate. Below that, there will be one geomembrane layer, and below that, there will be a layer of a compacted soil, which is normally clay, which has very, very, very less coefficient of permeability. So it very low permeable soil, which is normal, which is basically clay. Which the for the clay, the coefficient of permeability is less than 10 to the power minus and 7 centimeter per second. So similarly, apart from single layer, there is also double layer liners where geonets are used. Geonets basically helps in detecting if there is any leakage. So two geomembrane layers are provided, and in between two geomembrane layers, there will be one layer of geonet. So geonet can allow the later movement of the leachate. You can take out the leachate laterally and basically prevent the further percolation of the leachate into the ground. So the correct answer for this question is 0.1524 centimeter, which is around 60 mils. The third question is which strategy has the least preference in integrated solid waste management in relation to environmental benefits? Mhm. Yes, the correct answer for this question is landfill. Yes. The correct answer for this question is landfill. Um, the pyramid we saw in the waste management hierarchy. So landfill comes in the disposable section, even though it has the largest amount of volume all over the world, but it is the least preferred. Other components like composting, waste to energy, recycling has some advantages, disadvantages which we discussed earlier. So correct answer is for this question is landfill. Another question is next question is in solid waste management, waste utilization is by, accomplished by basically what are the sequence of 3 R's and which are the 3 R's?
Sir, option D.
Yeah, D option is correct. Reduce, reuse, recycle. Same reference you can use is the same diagram which is for waste management hierarchy. Reduce, reuse, recycle. Next question is the amount of solid waste generated per capita per day in small cities as per CPCB. The unit will be kg per capita per day. The correct answer for this question is point 0.1. For small cities, it is point 0.1. Yeah. The next question is uh, this we can go to which of the following is the most suitable method for municipal solid waste disposal for an inland village with sufficient land area. If we assume there is a village which has sufficient land area, which method will be more preferable out of the given options? Yes, the correct answer is composting. So, because in general, in case of India, we see, and if we specifically go in case of village, more proportion of waste would be in organic waste. That can be, if we do segregation, we can easily convert it into composting. And open dumping is the least preferred option. Open dumping won't be answered for. Is the least preferred option. So composting will be the correct answer in this case. Next question is why open burning is not an acceptable practice for solid waste management. Yes, C is the correct answer because it causes several environmental issues. Open burning basically can lead to emission of various toxic pollutants into the environment, such as furans and other toxic gases. Like in case burning of tires, there will be emission of benzene and other compounds. So for this question, C is the correct answer because it causes several environmental issues. Another question is, which was the first city to have an established system for waste removal? The correct answer is Athens. In around 320 BC, they were the first one which took some steps in direction of preventing the open dumping. Yeah, Athens. Next question is amount of solid waste generated kg per capita per day in medium cities as per CBCB. So the previous question was around the small cities. This is for the value of medium cities. For medium cities, the value is around 0.3 to zero point 0.4 kg per capita per day. Next question is, which is the intent, the term integrated solid waste management system? Yes, yes, all of you are correct. D option is correct. Uh, as we have waste generation, then we have um, source separation, and then we have collection, transfer, and then we have treatment and recovery, and then we have disposal. So D option is correct. The next question is sanitary landfill designed to provide protection against potential groundwater contamination with leachate? Yes, the correct answer is yes. So I have one more question for you guys. Is the assignment one or the week one assignment is discussed, or the answer key is uploaded? So till when you have time to submit the responses? Okay. 9th of August. Okay. 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 Cool. Okay. The next question is, the amount of solid waste which is generated for large cities, kg per capita per day, as per CPC. And the correct answer for this question is 0.5 kg per capita per day. Uh, does anyone have idea about what is the Like if currently, right now, if we see what is the per capita waste generation for India and in what range it is. Sir actually discussed it in during the first week lectures. So I think that value is around somewhere between zero point 0.6 to zero point 0.7 kg per capita per day. For bigger cities, the value is on higher side, and for smaller cities, value is on lower side because the your economic status somehow influences the how much you consume and your consumption, and which directly influences the amount of waste generation. So in bigger cities, the amount of waste generated is more, and comparatively in lower tier cities and villages, the amount of waste generation is on the lower side. Yes. So moving on to next question. In waste management hierarchy, what do we mean by diversion of waste? Like the answer. Okay. Sorry. I skipped few questions. Yeah. What is the answer? Like, how much energy is saved when aluminum is recycled? This we have discussed in this class also, and sir also discussed the in during their lecture. When we recycle aluminum rather than using virgin aluminum, we can do it in one third of the energy. So based on that, you can determine. Yes, the correct answer is 0.66. C. Correct answer is 0.66. So as we know, we use only one third of energy when we use recycled aluminum. So that means we can save two third of energy. So two third of energy comes around 0.66. So the next question is, in waste management hierarchy, what do we mean by diversion of waste? Yeah, so correct answer for this question is divert waste away from the landfill. That's what we are doing in the whole solid waste management thing, because in landfill is the like ultimate, the least preferred method. We don't want to directly divert our waste into landfill. Before landfill, we have multiple. Before landfill, we have various methods such as reduce, recycle, Uh, we can recover materials. We can restrict the use of material by avoiding the use of material. So we have different ways so that less and less material end up in landfill. So the whole idea is to divert waste away from the landfill. Uh, Next question is, uh, what are the ways to divert the uh, what are the different ways to divert the waste away from the landfill? Yes, all of the options are correct. Apart from landfill, these are the different ways which we can handle the solid waste: recovery, incineration, composting. Each component has their disadvantages, as we discussed earlier. So in this case, all the methods are responsible for diverting the waste away from the land. So what are the disadvantages of incinerating the solid waste? There could be multiple correct options here, more than one answer, maybe, in this question. Yes, B and C is the correct answer. In incineration, the major two problems which are giving in these options are air pollution. Incinerating, if you don't have proper air treatment devices, you will end up having air pollution. And second problem is, because of that air pollution, there will be stigma around incinerators that they cause air pollution, so people won't allow the construction of these incinerator plants near their houses. It is similar to landfill sites. It is same with the sewage treatment plants. So because they can be correlated with foul smell and um, air pollution. So there's a social
So the
stigma which, yeah.
so, I just wanted to understand your view on this. So incineration is something that is that causes air pollution. Is it fair to say, or is it just a stigma, like something which is perceived this way?
If we just talk about the technology, we have technology that we can uh, treat the whatever gas is generated from the incinerator. So in terms of technology, we are capable. We can do it. There is no issue. Like whatever air will come out of the stack of the incinerator after treatment, it won't be harmful. Once it get diluted, whatever, if it has some amount, it will be diluted. So when it goes out into air, the values will be below what standard says. So in that sense, it isn't a problem in terms of technology. In terms of technology, but on the other hand, because if we just specifically talk about India, most of the time, uh, as sir also explained in the class, that even the plant which have devices which can treat gases, different flue gases coming out of the incinerator, they sometimes switch off those devices. Uh, but although when you switch off those devices, the flue gas treatment methods, the treatment systems, those actually uh, go bad if you don't use them regularly. So in terms of technology, there is no issue. But in India, we normally, uh, whether we are using those, I won't say in case of India, I'm not very sure about it, but if we don't use those flue gas treatment systems, or we switch off, we don't use them, either we don't have them in our incinerator, or we switch off them sometimes. So that will cause problem. So people don't want to take risk of uh, in that sense. So I don't think in terms of technology it is a concern if we install proper technology for the flue gas treatment, then it won't be an issue.
Okay.
There are few gases which are generated from various ways, like different carcinogenic gases are present, but those gases uh, uh, we can filter out. Most of the things can be filtered.
Okay, so it's 100%, or is it some percentage that we can give to it?
100% I won't say, and I will get back to you for about it in the next class. I will
Sure.
further study on my behalf, and I will let you know.
Thank you.
Because even like there are standard for like how much gas we can liberate out in air. After that, there will be dilution also in air. So there is concept come air pollution. There concepts comes with like mixing height, mixing height of pollution. Then there is further goes to which season it is, whether where we are in winter or summer, because mixing height varies. In winter, mixing height is reduced, and summer mixing height is more. So based on that, like every area or every country should come up with particular standards, and based on technology, how much pollutant it can remove, particular pollutant, and how much we can like release into the environment, so that after dilution the level is so low that uh, within 8 hours of exposure or 24 hours of exposure, it is not harmful to us. So in that sense, there are multiple factors. So currently what technology we have, and how whether they are able to remove 100%, I will come back to that in next class. I will probably discuss with sir, and I will tell you next class. Okay.
Thank you.
So next question is, which material is used as lining in landfill? The correct answer is for this question is geomembranes. We also use clay. We used to use clay as because it has very low permeability. It also acts as a liner. We use it as a compacted soil layer below geomembrane. But if we specifically talk about liner geosynthetic material, geomembrane is the correct answer. Next question is membrane used in landfill lining are. So the correct answer for this is impermeable. Next question is what are the advantages of waste to energy approach? This could be a multiple correct answer. This could be a multiple correct answer. So the correct answer for this question is energy recovery and less waste diverted to landfill. C and E. We have high costs normally in waste to energy. We need high skilled labor, which also contribute to high cost, and we have stack emission and toxicity always. So these are the disadvantages of this waste to energy approach: energy recovery and less waste diverted to landfill is some of the advantages. In mm, Western European countries, there's very less waste which is diverted to landfill, less than 5%, less than 5 to 10%. Specifically in Scandinavian countries, um, the waste diverted to landfill is very less. So they use waste to energy approach. So the waste to energy approach in terms of incineration pyrolysis is used in Western European countries very much. So for the like flue gas treatment terms, we can kind of take a parallel from those countries. Like if they are able to do it, but because they have higher per capita GDP, for them cost they might not see cost as a big barrier. But if we only see specifically to the stack emissions and toxicity of it, they're able to manage the stack emissions. So I I think if we take that parallel, uh, but that question will I will further clarify that question in the next. So the next question is what are the primary gases released from the landfill? Yes, the correct answer for this question is methane and carbon dioxide. Normally, if we want to take a value, like proportion, if we take an approximate proportion, it varies from 45 to 65% uh, for methane and carbon dioxide. But the main gases are methane and carbon dioxide. You might have small traces of other gases also, but the main gases are methane and carbon dioxide. Same due to anaerobic digestion. The four-step process we discussed: hydrolysis, acidogenesis, and methanogenesis. So basically, in hydrolysis, the breakdown of bigger hydrocarbons by addition of water molecule in presence of water molecule or by water molecule. Then we have acidogenesis, where um, basically sugars and amino acids are broken down into volatile fatty acids, and fatty acids, and then those volatile fatty acids, the large fatty acids, are further broken down into acetic acid and a small amount of hydrogen and CO2 in during the process of acetogenesis, and further those acetic acid generated in the third step is further broken down by methanogens into methane gas in the fourth step. During this whole process, methane and carbon dioxide, which is a major gas. So the last question for today's presentation is what is the coefficient of permeability for the compacted soil? So in when we see the diagram when we see the diagram of single or double liner, the bottom layer will be the compacted soil, which is usually clay. So the question is, what is the coefficient of permeability for that layer? So if you know the permeability for clay, you can directly answer. Yes. So the correct answer for this question is coefficient permeability is less than equal to 10 to the power minus 9 centimeter per second, which is equivalent to that of clay. So for today, I only have these many questions. Next class, probably I will discuss the questions from. Yeah, I will share the PPT. I have to share the PPT and video both. I will share the PPT, no issue. Uh, from next time, I will try to change the meeting platform to Google Meet probably. I will send the mail. If they allow, we can change the meeting link. Uh, for today, I'm done with the meeting. If anyone wants to ask anything or want to contribute something else, they can say. We have around 5 minutes. 5 minutes more. We can, if anyone wants to talk, wants to say something, or want to suggest something, want to suggest changes in the way of teaching or something. If from the next class, like if you want to suggest any changes, like we can go in a particular way, or so that it's better for your understanding. You can suggest where I will try to work on that if you if you want.
Sir, it would be helpful if the numericals are also discussed.
Yeah, numericals will be there in the upcoming classes because um, this session was only specific to the first week. In first week, there are not much numericals. Later on, there will be numericals. Specifically, solid waste management has more numericals, like good numericals on operation research, linear programming, where you basically optimize the path for transportation of waste. So there we have good numericals, and there are more numericals on like calculating the calorific value of waste, what you get. There were numericals in later sessions, I think.
Yes, sir. If those would be discussed in the session, live session, it would be more grateful, sir.
Yeah, I will definitely discuss
Uh,
later.
yeah, thank you, sir.
Mhm. So,
Hello.
thank yes, sir, please. Yes, sir.
Myself, Rudara
Yes, sir.
from AP State, Andhra Pradesh.
Yes, sir.
Sir, in the examination point of view, for every week, I mean, for every lecture, we have some PDFs, sir. Those videos and PDFs are enough for the examination point of view, or otherwise, we will going to see the textbooks also, sir, for the preparation point of view.
Yeah, sir, actually, the issue is from my end, I won't be preparing any exam papers. So when like the sessions you are having for doubt clarification are session which are taken by a PhD student which who got PMRF. So we have certain hours of duty. So actually we won't be the one who is preparing the exam papers. So you might be having some discussion forum or every week one live interaction with TAs and the and Professor BK Dubey.
Okay, okay, okay.
Am I right? You are having right? You have every week or every 2 weeks you are having
Yes, sir,
some.
but what I am observed, I wrote so many NPTEL exams, sir. What I observed from I wrote from the past 2018 onwards, sir.
Mhm.
So what I am observing that we are not seen what we call the main speaker in any way, sir. Till now.
Okay, they won't ask. for today, the meeting is complete. Now we will meet on probably next week from 6 to 8 only. You can leave the meeting for today. No issue.